Hello everyone, I'm Dr. Layla S Tawfeek, lecturer of biochemistry and molecular biology at Faculty of Agriculture, Cairo University. My research is about bioactive properties of some phenolic compounds fractionated from pomegranate peels crude juice. Okay. As we know, agriculture and agro-food industrial processing produce large amounts of waste and byproducts, which represent a critical issue for both environment and international economy. So the main challenge nowadays is using these non-edible parts as a renewable and cheap source of added value bioactive compound to introduce new, more sustainable and natural alternatives to the market. As we knew previously, several extraction methods have been reported for recovering the bioactive compounds are using organic solvents, which may contribute to toxicity and high volatility, also non-renewable. So there is a growing need for green and sustainable alternatives. So the main objective of this work was to investigate the bioactive properties of some phenols fractionated from crude juice of pomegranate peels as agro-food byproducts which produced without using a solvent. The material and methods was like we collected and identified the pomegranate peels, then produced the pomegranate peels crude juices without using a solvent. After this, extraction of phenolic compound, then fractionation and identification of these phenolic compounds. After identification, these phenolic compounds were subjected to the estimation of their bioactive properties, for example, antioxidant, antibacterial, and cancer activity. Also, cytotoxic effect were also evaluated to check the safety of these phenolic compounds. The production of pomegranate peel crude juice was conducted using mechanical press only without using a solvent to prevent the harmful effects of these solvents on the human health and the environment. After production, the crude juice, phenolic compounds were extracted using solid phase extraction chromatography. After this, these phenolic compounds were fractionated into their main components by using thin layer chromatography. Moreover, these phenolic compounds were identified using several spectroscopic methods such as FTIR, mass spectroscopy, and NMR. According to the data of the chromatographic and the spectroscopic methods, this data revealed the presence of 5 phenolic compounds, which are gallic acid, ellagic acid, catechin, quercetin, and vanillin. As we mentioned, these phenolic compounds were subject to the estimation of their bioactive compounds properties, and we'll start with the first activity, which is the antioxidant activity. From the figure shown in front of us, we can notice that vanillin showed high scavenging activity by DBPH, which is a B5, while ellagic acid, which is B2, exhibited higher reducing power and metal chelating activity in comparison with the other phenolic compound under study. For the antibacterial activity, was evaluated against 2 types of bacteria, gram-positive 2 types and gram-negative bacteria, which are common human pathogens. As we can see from these results, that ellagic acid, which is B2, exhibited significant antibacterial activity against all the tested bacteria. According to this, MIC, which is the minimum inhibitory concentration, were conducted on ellagic acid, which is B2, which revealed that ellagic acid showed high antibacterial activity against Staphylococcus aureus and Pseudomonas aeruginosa. Staphylococcus aureus gram-positive and Pseudomonas aeruginosa gram-negative. About the anti-cancer activity was accomplished against two types of cell lines, MCF7, which is a human breast adenocarcinoma cell line, and HCT16, which is human colon cancer cells. Dealing with the MCF7, we can notice that catechin, which is B4, decreases the viability of MCF7 breast adenocarcinoma in comparison with the other phenolic compound under study. Also, catechin reduced the viability of HCT colon cancer cell lines in comparison with the other phenolics under study. The cytotoxicity potential of these phenols under study revealed no toxic effects at the concentration used in the study. From the information data, we can summarize that phenolic compounds that recovered from agro-food byproducts using sustainable extraction way can be used as raw material or as novel product with health benefits, creating industrial with added value. Thank you all. And I have a special thanks to Lydia Wagner for her patience and kind treatment. And also I thank all the participants, committee, and all the organizers. Thank you so much.